The technology for AC and DC conversion has evolved significantly over the years, with advances in power electronics, control systems, and materials science. For example, modern power electronics allow for the efficient conversion of AC and DC power using semiconductor devices such as diodes, transistors, and thyristors. Control systems enable precise regulation of power output and improve the efficiency of power conversion. New materials, such as wide bandgap semiconductors, offer improved performance and higher efficiency in power electronics. AC and DC conversion is also a critical factor in the transition to renewable energy sources, such as solar and wind power. These sources typically produce DC power, which needs to be converted to AC power for local power distribution. In addition, energy storage systems such as batteries use DC power, which needs to be converted to AC power for use in the power grid or for powering electric vehicles. The continued development of AC and DC conversion technology will be essential for meeting the energy demands of the future, improving energy efficiency, and reducing greenhouse gas emissions. By improving the efficiency of power conversion and enabling the integration of renewable energy sources and energy storage systems, AC and DC conversion technology will play a vital role in achieving a sustainable and secure energy future. When deciding whether to use AC or DC power, there are several factors to consider. Distance: DC power is more efficient over long distances as it experiences less energy loss due to resistance than AC power. However, AC power is more convenient for local power distribution as it can be easily stepped up or down in voltage using transformers. Device requirements: some electronic devices require DC power, while others can operate on AC power. Devices that require DC power include computers, smartphones, and batteries, while devices that can operate on AC power include fans, light bulbs, and electric motors. Safety: AC power can be more dangerous than DC power due to its ability to induce electric shocks and cause muscle contractions. However, DC power can also be dangerous as it can cause electrochemical reactions in the body that can damage cells and tissues. Cost: the cost of AC and DC power depends on the specific application and the cost of the required components and infrastructure. In general, AC power is less expensive for local power distribution, while DC power is less expensive for long-distance power transmission. In summary, the decision to use AC or DC power depends on the specific requirements of the application, including distance, device requirements, safety, and cost. While AC power is more convenient for local power distribution and is safer for most applications, DC power is more efficient over long distances and is required for many electronic devices. To convert AC to DC, a rectifier circuit is required. There are two types of rectifier circuits, half-wave and full-wave. A half-wave rectifier circuit only utilizes one half of the AC waveform to produce a pulsating DC output. In contrast, a full-wave rectifier circuit utilizes both halves of the AC waveform to produce a more continuous DC output. A bridge rectifier is another type of full-wave rectifier circuit that is commonly used in power supplies. It consists of 4 diodes arranged in a bridge configuration that allows for full-wave rectification of the AC input signal. Bridge rectifiers can produce a higher output voltage and current than other rectifier circuits. To convert DC to AC, an inverter circuit is required. There are two types of inverters, pure sine wave and modified sine wave. Pure sine wave inverters produce a smooth AC output waveform that is similar to the waveform of grid power. They are suitable for powering sensitive electronic devices such as computers, televisions, and medical equipment. Modified sine wave inverters produce a stepped or choppy AC output waveform that is not as smooth as a pure sine wave. They are suitable for powering simpler electronic devices such as fans and light bulbs. In summary, rectifiers are used to convert AC to DC, while inverters are used to convert DC to AC. There are different types of rectifiers and inverters that are suitable for different applications and requirements. The choice of rectifier or inverter depends on factors such as the input voltage and current, output voltage and current, and the type of load being powered. Advantages of using AC power include: easy distribution. AC power can be easily stepped up or down in voltage using transformers, which makes it convenient for local power distribution. Reduced energy loss. AC power experiences less energy loss due to resistance over long distances than DC power. Efficient motors. AC motors are more efficient than DC motors, which makes them suitable for many industrial applications. Safety. AC power is safer than DC power for most applications, as it is less likely to induce electric shocks or cause muscle contractions. Advantages of using DC power include: compatibility. Many electronic devices require DC power, which makes it a necessary form of power for many applications. Energy efficiency. DC power is more energy efficient than AC power for some applications, such as charging batteries or powering LED lights. Reduced noise. DC power produces less electrical noise than AC power, which makes it suitable for some electronic applications that require low noise levels. Reduced electrochemical reactions. DC power can reduce electrochemical reactions in the body when used for medical applications. In summary, both AC and DC power have advantages and disadvantages, and the choice of power depends on the specific requirements of the application. AC power is more convenient for local power distribution and is safer for most applications, while DC power is more compatible with many electronic devices and is more energy efficient for some applications. The use of AC and DC conversion is ubiquitous in modern life. Some common applications of AC and DC conversion include: power generation. AC power is typically generated by power stations and distributed to consumers through power grids. DC power is used in some renewable energy sources, such as solar panels and wind turbines. Electronics. Many electronic devices, such as computers, televisions, and mobile phones, require DC power. AC power is typically used to power the chargers for these devices. Transportation. DC power is used in electric vehicles, while AC power is used in electric trains and trams. Medical equipment. Some medical equipment, such as MRI machines and X-ray machines, require AC power. DC power is used in some medical equipment, such as pacemakers and defibrillators. Industrial applications. AC and DC power are used in a wide range of industrial applications, such as electric motors, welding machines, and power tools. In conclusion, the use of AC and DC conversion is essential for powering modern life. The choice of AC or DC power depends on the specific requirements of the application, and rectifiers and inverters are used to convert between AC and DC power as needed. To summarize, AC and DC power have different characteristics and are used in different applications. AC power is convenient for local power distribution, is more efficient for some industrial applications, and is generally safer for most applications. DC power is compatible with many electronic devices, is more energy efficient for some applications, and produces less electrical noise. Rectifiers and inverters are used to convert between AC and DC power as needed for different applications. AC and DC conversion is essential for powering modern life, and its usage ubiquitous in a wide range of applications, from power generation and transportation to electronics and medical equipment.